Hello everyone, I've got a very quick video here just to talk about how to calculate centralized values. Now this is a topic that I've actually ended up teaching in biology as part of an ecological sampling and data analysis exercise where you're given particular numbers related to samples that have been collected, and you've had to calculate particular values from that, particular averages, let's say. Now there are three kinds of centralized values that we need to consider: the mean, the mode, and the median. So for this, what we're going to do is just have a set of numbers to consider. So let's imagine we've got this set of numbers. We've got 2, let's go for a 4, another 4, a 5, a 6, a 7, and a 10. So we've got 1, 2, 3, 4, 5, 6, 7. 7 numbers within our particular data set. Now the mean is the average of a collection of data. So let's just make a note of that there. So the mean is the true average of that data set. So to work out the average, if we add them all up, so 2 plus 4 plus 5 plus 4, plus the other 4, sorry, plus 6 plus 7 plus 10, and then divide that by how many numbers we've got, which in this case is 7, then what we come out with is a value of 5.4. So it's good standard procedure to give values to one decimal place extra than what we have in our data set. So what we've worked out is that we get a mean for this set of values of 5.4. There's our mean value. Now the mode, if you're asked to work out the mode, is the most popular value of a collection of data. So let's just put that down there. The mode is the most popular value in a set of data. Now clearly you can see from this set of numbers that we're using here, we've got a number 4 there, we've got a number 4 there, so we've got two lots of 4. So the mode in this example would be 4. Let's do 2 arrows there, which leaves us with one more centralized value that we can work out, and that is the median. Now the median is the proper word to describe the middle value of a collection of data. So to get the middle value, what we need to do is line all the numbers up in numerical order, lowest to highest, and then find what is essentially our middle or central number. So if we go 1, 2, 3 this side, and then we go 1, 2, 3 this side, you can see that that leaves us with a central number here. So our median in this data set, our middle number is 5. And there we have it. Here are our three centralized values: the mean, mode, and median. And we've calculated them as 5.4, 4, and 5. Now the question that you may be asked is, why bother? Why do we calculate centralized values from a set of experimental data? And that's a good question. And the reason why you do, and there's a few, primarily is that it allows us to compare with other sets of data. So I'm just going to make a note of these here, and these are definitely the things in an exam question to pull out. So 1, we can compare with other data sets. And in science, you know the value of comparison. It's always important thing to consider whether you have a set of comparative results to know whether you're on track or not. Another reason why is that it allows us to look for trends and relationships. So I'll put that down there. We can look for trends or relationships in the data. And finally, it actually just gives us a general overview of the findings. So we'll just put there general overview, because when we make a conclusion upon this data, we can use these centralized values to essentially verify what we're saying to really give some validity to this conclusion. We can actually use data to support any arguments that we give, either for or against a particular point. So there we've got just a very quick video on these centralized values. We've got the mean, mode and median. We're looking for the average of a collection of data for the mean. We're looking at the most popular value in a set of data for the mode, or we're looking at the middle value of a collection of data for our median. Okay, hope all that helps.